тут принято говорить «Привет, Лужники». Я рад вас приветствовать на нашей секции Platform.
Dear friends, welcome everyone. It's a section Platform Engineering. We have 6 presentations today about what web platforms could be and how do they work. And before we begin, I would like to make 2 household announcements. Let's keep our questions. You can see QR code on the side screens, and you can send your questions to this chatbot. And also, at the end, we will vote for speakers at the very end. Now, Dmitry Tseluyko will be the first speaker, and he will be speaking about the auto standing. And this is like a super classy platform.
Всем привет. Меня зовут Дима.
Hello, everyone. My name is Dima.
Я, соответственно, руководитель департамента разработки
I'm the head of the Department of Developing Information System, DIT, in PT, or Positive Technologies Company. Our department
разработка информационных систем
basically developing information systems in the PAS, SAS for external and internal use. And today I would like to introduce to you one of the projects of our department
разработке методологии автоматизированного
in developing the methodology of automated product stand, test bench.
Хотелось бы до этого спросить у вас, как вы думаете,
But before that, I would like to ask you
сколько нужно, чтобы вкрутить лампочку?
how many speakers it takes to change the
Я думаю,
bulb.
как минимум 10,
I think
потому
at
что
least 10.
вкручивать лампочку и
At least 10, because one is changing the bulb, and the 9 other guys are, sharing the experience and telling him what to do. I wouldn't be sitting here today at this station. I wouldn't be delivering to you this kind of automatic test, bench or stands. And thank you for everyone who helped me to get ready for this presentation. My grandma has a jubilee. She's 100 years old. Can you believe that? And hopefully she's watching us. And this is your favorite topic of automatic testing grounds, test bench.
что этот доклад все-таки?
Now, let's dive deep. And what is a product stand and how do you do it? How do you prepare it? In my experience, I've had several definitions of what test bench is all about. Some people would say it's just a facility with equipment. Other people would say it's a hardware. It's a hardware with some software installed on it. Yet others would say it's basically like a stand. In Russian word stand is like a bus stop stand. But I think it's more about IT industry evolving, and now you can call it like it's a whole information system, infrastructure, and equipment which would be tuned up to do different kind of work, be it the testing, be it the product, or research or something else. Those test units could be based on the just a bare hardware, or on the VMs, virtual machines, on the virtualization systems and clouds, and so on. When we first began studying this kind of testing processes in our company, we would come to the product development team and ask what kind of problems you have. And they would give us their pain points, that 90% of all test units configurations, they are the same day in and out. And mostly it's done manually by different departments. Why is that? Well, I guess because the development teams, they have their own backlog, and they implement different business features, and up until building this test unit or bench, they simply don't have enough time to do that, and it's not their responsibility. And so kind of responsibility kind of washes down and goes into back burner, and then totally different unrelated people begin to do that. Those who are not related to deploying product or building new releases. And
Продуктовые команды в основном
And
своим бэклогом заняты.
mostly product team are preoccupied with their backlog. So it's like a QA, support engineer, as you know, teams and stuff begin to do that, begin to do all the testing.
Очень
And
многие,
also,
которые сделаны по
many deployers, deployments, they've done differently, and it makes it hard to unify and to automate this process. So there was a notion on the market that you cannot automate test units and test beds, and you got to do it manually by hands.
собрали мы следующие требования.
So all in all, we came to the following conclusion: like, the problem is that we have like a manual processes between deploying those test units and or test consoles and delivering products for testing, testing those products, and configuration of connection between integration and products.
Были ручные процессы по
And also we've had some manual products in terms of like loading data. For example, QA guys that would go to get resources and then infrastructure would be brought in TeamCity and be deployed by a certain parameters, and then they would launch some kind of manual scripts in terms of loading data, and all of this would be done in a kind of one-off situation for just specific products and just specific infrastructure. The next problem could be legacy systems in deploying different products, and legacies. Some have Ansible, some have Bash and Salt, and different legacy systems, and so it makes it extra hard to do any universal solution to install product or testing product, and also integrating this product as a part of like a product family. Next problem is dependency on a provider, and usually like solutions is kind of attached to a certain provider, and once you are dependent on provider, you need to implement some new solution for development. Another problem is that there is no one single entry point to get your test bench for any goals. Like, who do you go to get your test bench? Some people deploy infrastructure, yet others prepare deploy, yet others test it, and there are some engineers, support engineers, who do manual configuration of connection between different products. And this kind of like all over the place or uncertainty would erode zones of responsibility. And there is also certain unpredictability, and there is no like clear reporting on using resources when you do not really know what kind and what volume of resources you need to plan for ordering test beds and some kind of long time forgotten test beds that would not be able to deploy for product testing. And also lack of resources and planning would also affect us, so that you would not be able to deploy your test unit at once. And also scaling up is another problem. When I'm speaking about the scaling up, it is not only scaling up providers, but also scaling up products, so that you would be able to get a new product. At a new product, you had to develop a new test unit, and also scaling up deployment schemes and other things. All of those problems. To solve all of these problems, we needed to develop some kind of universal tool to automate and do product research, testing, and teaching infrastructure for a company, which would be independent of a placement provider. Well, let us see who may need it and who we're working for. And our clients in this kind of situation have got like, okay, so first of all, it's a QA, R&D, ESC support. They need research test benches to try out their assumptions and also try out incidents, localizing incidents, and also building guidelines and documents for those. Education guides, they need their test benches to do kind of very fine work. And for our sales department, we also need test units to demonstrate capabilities of a product and run some scenarios and so on. For standoff, we also need a test bed or test unit to simulate infrastructure attacks and also protect it. And also clients need a product test bench. So depending on a goal, we may have different clients, like maybe call infrastructure where we just deploy, we create VMs, virtual machines, and set up clouds or DNS and network correlation if needed. And in this way, we pass on this test bench to a client. And also, we have like a distributed infrastructure. When you just provide like a basic bare infrastructure, we copy distributive so that the QAs would be able to double check this distributive itself. When you install independent distributive in an isolated infrastructure which is cut off from the internet, then what we call a pure installation, it's an infrastructure with a product or set of products, and also installation with data and installation with like periphery. For training purposes, we had to alienate this test bench and give it to schools and universities for lab works, and we also need to prepare the whole perimeter to ensure safety, like terminal, back proxy, fine-tuning SSH RDP access, and also maybe also installing VPNs. And for QAs, it was important to be able to launch this whole testing process from pipelines. And also, as I've mentioned before, you also can get like undelivered products so that deployer would be able to test it. Also, some of our clients, they needed to get distributive independent ones for deploying them in isolated environments. So all in all, we out of all this, we kind of build the list of the following goals. First is to develop test bench deployment methodology and checking its viability. The second goal could be ruling out kind of manual processes, getting rid of manual processes between creating a test bench and its verification. And also to ensure that there'll be automatic checking of the test bench, its tracing, logistics, logging in, and also being able to isolate infrastructure from the users and provide one single interface for test bench inquiries. And also to develop a tool to place those test units with different providers. And also reporting for resources and calculating cost of ownership and the planned cost which you have to order for resources needed. As well as another goal is to build a set of configurations. I mean, some library of knowledge about products which will be used for automation purposes. And also multi-tenant, that is delineating access, tiering up access for different clients and organizations, and also basically scalability, so that we would be able to fine-tune and to allocate resources. Well, how about solutions? And one solution, it looks like we can describe methodology, define our requirements, and also build an automated system which would have one single interface for all of our clients. So we came to a conclusion that you can automate it, and you cannot do it manually. You should not. What we decided to do that some kind of one-off specific solutions and methodology, it should be one methodology and one point of entry for getting all of your test benches or units. Let's see what kind of configurations we needed. For education, we needed all-in-one test unit, slow load for teaching different products like a CM, which will be installed on the virtual machines in the cloud. Yet another example would be medium-low profile of productivity with configuration of integrated products, which will be integrated between one another, installed on virtual machines of a virtualization system. And also more complex example, it's a high-load profile of productivity with a hierarchy of installing CMs with a master and several slaves, which will be integrated with yet another products, also based in cloud on virtual machines. So basically, what configurations are possible? Those that I've given you, it's just a tip of the iceberg of those configs which would be possible in our company. And we also have other ways, other configurations of different components and products. Like some product can be installed if you can add your components to a separate resources. Some are taking their database to a separate server, and some are, taking out some workers and some queues. Also, you can do different combination between products and different combination of their components, installment ways, providers, and localization. So you can play with all these components. And this kind of versatility of different combinations enables us to get one single point of like a built-in test unit based on inquiry, where you have like a specific parameters for a specific testing bed. To make that it would be possible, you need to describe what your product is all about in a certain config file, and then we'll come to that later. And to do this, you need, first of all, take existing product installers and wrap them up, and to provide methodology describing products' uniqueness or specifics. And now let's move on to the methodology concept itself. Our methodology can be split up into several preparation and main stages. Number one, we need to prepare database for products, where we show those competences that product teams have, and basically what kind of productivity profiles are possible. How can we do installments? How can you integrate this product with the different products? And these kind of competences are owned by the product developers, or maybe they're also interconnected DevOps teams which are involved in deployment of this particular product. Well, the specification file itself is being prepared from the EML description on a certain pattern, which specifies main product parameters, like a name of the product, some metadata, version, code, which we later on can use to build architecture description based on the backstage. And also you specify the deployment path, and also productivity profiles component of the product and their interrelation connection with different products, if any, and also some licenses and localization, you name it. It's quite a short file, but still it gives us descriptions of product capabilities in this kind of a describing form. So those specs and their state are placed in Git, and we can see their different versions and changes. Now let's move on to the process of building a testing unit itself. And so first of all, we get an order from client that they need some kind of test unit. We register it and double check the access rights for specific users and or organizations or companies that this user is representing. So this application has a lot of fields. Application from a company. It's about the list of specs or what products will be deployed, and also specific combinations of those parameters based on those specs. And then you select like particular ones. Like I've said before, this would be the installment type, licenses, productivity, and also we specify the parameters of interconnection, because clients may come with their own clouds and or resources, and that's why we need to specify like what provider we should connect to and where do we install it. Localization type of the testing unit, it tells us like where we stop in this whole process and to provide result to the client. Contacts of our client, and also we need to first of all to decide on their rights, to sign them up, and also to give them some feedback on to give them some kind of notification on what is going on with their application. We also need to give it back in the system. I mean, we need to do some kind of like periphery to alienate this test unit from the company. I mean, you build some kind of terminal machine and reverse proxy, maybe to install a VPN and so on. Do you need internet access, delayed start time? We need it all to save on resources. If you know that Lapa will begin in a certain period of time or time point, we do not need to build this test unit right now. We can defer it, and the system will define when to build it. The second one is TTL. It's a lifetime of this test unit. Also needed to save on resources and not to create like a forever testing units or benches without a special need for it. There are like automatic mode of canceling those stands or removing those stands. There is just like a certain time point after which termination will happen, and also a number of copies that we need to multiply. For example, to doing some lab research, it's important for each student to have identical copy of this testing unit. Next, kind of standard applications, we can do presets, like a user presets, so that users would not have to fill up all those applications every time that they need a test unit. We have some names, so you can just choose your preset, and you can launch the whole process of deploying your stand. And after we got an application, we begin to build a manifest. The system loads from the Git repository product specifications and then extracts those parameters and combines them with parameters specified in application. So basically, we built EML Kuber-like manifest in which you, out of this application, you just put in data and parameterize or build parameters and steps of a certain order or sequence for execution. And each next step will be a separate controller or a separate system executing this step, and you identified from the manifest by certain certain dots. We'll see them. There is one manifest for all controllers which will be used in the future. Now, this manifest is sent on based on the deployment stages. Stage number one is building an image. If the image has not been prepared, it's built according to the specs from the manifest. If it had been already created, you take whatever image you've had. It's like a caching,
Есть еще возможность по подгрузке локального образа, например.
It is also possible to load a local office from Windows.
Содержит основные его.
Now, this image has like a main parameters to prepare it. So we have
где взять
basically operation system, where you take distributive and also additional teams, additional orders, I'm sorry, commands for building the image.
API version и kind, который
And
позволяет
also API version and kind, we can see those marks,
какой раздел
which enables us to define, or how can I say it,
контроллеру. Вот этот раздел
like
как раз для
a certain controller is working on which section, like each section for each controller.
Дальше необходимо подготовить инфраструктуру. Система
Next, we need to prepare the infrastructure. The system is building those virtual machines and setting up DNS and cloud and makes some kind of network, fine-tuning and network connections. If needed, it throws it back or prepares like reverse proxy or builds a terminal machine if you need to give this test bench outside. So the manifest in infrastructure looks like that. You can see it on the screen. So out of productivity profile for a specific product, you put in data like specific parameters, like about the number of kernels and memory, and also you write in here network DNS settings, and also you can do additional commands for
дистрибутива на
for example, for loading distributive into this infrastructure.
дистрибутивом.
And you get this kind of infrastructure with the distributive. And also the next actions related to
Параметров этого
filling
манифеста
up all these parameters of this manifest after you steps taken.
необходимо заполнить
After you deploy this infrastructure, you need to fill up IP addresses, DNS, and maybe some Kratos.
сворачиваются,
And also at this stage, you just deploy this kind of like contours like VPNs and different access tools.
дается в некий контроллер управления зависимостью.
And then the management gives passed on to the dependencies controller, where you defined communication or connection of products between one another, and also the way of like the order of or sequence of carrying out those tasks. So system describes what components connected to what kind of ports will be used, and also access parameters are specified in the document. And also after that, the manifest sent to deployers, which will double check resource availability, amount of those, and also they parameterize those specific installators for each product and do the installation of each product in a separate way.
Манифест итоговый
So this manifest, the final manifest, looks like a big sheet from different stages with marks from different controllers with parameters. You can see IP addresses right here, and you can see those credentials and DNSs.
получают
Deployers get
это описание.
those stages and descriptions in a certain like order sequenced. They install these products and then return the control to dependency controller, which automatically kind of configures communication between the products. At each stage,
Да,
you do feedback loop, and you show, depending, of course, on the process implementation, or where each of the test units stands, like a status model. We're going to come back to it, and eventually we get some kind of
в дальнейшем
like a test unit, which in the future,
необходимости
you can load data to this test unit. And data are poured into each product differently. Sometimes it's sequenced, sometimes API, sometimes through the database, and in some products there is a file kind of loading, uploading. It all depends on what manifest says for each case. And so after each of those stages, you double-check consistency of the test unit and communication between products and
выдается
those correlations, and you give out the final result. When the test unit is complete, a notification is sent to a client to their email that their test unit is ready, and access parameters are right there.
тиражирование, то есть
Scaling up,
более стенда
that is getting more than one copy of the stand, you can do it by making this process parallel, and
запрошенному в заявке.
by the amount required in the test. And
Детализацию и кастомизацию
and so you can do maximum like detailing, customization, and specifying parameters
да, схему
when deploying the profiles of productivity. And also, on the other hand, it simplifies and unifies approaches to different inquiries for test units, which helps clients and customers to
каждодневных их
in their daily,
выполнении
daily operations.
обязанностей без погружения в какую-то специфику продукта.
Without actually
Соответственно,
getting into the specifics of the products.
необходимости слежения.
So it frees the people just to track down the changes of the version of the product. Let's just follow the status.
Разворачивается очень долго. Некоторые
It takes some time to deploy some of the products.
или полтора.
It takes sometimes an hour and a half to deploy some of them. That's why
Состояние, что же сейчас
indication of the state is required, what is happening to the customer's query,
происходит на
the customer's ticket, so they should be aware of what is happening at each and every step.
Как только
As soon
систему заявка, она отправляется в очередь и
as it gets into the queue,
проставляется время наступления событий
you will see the time
развертыванию. То есть она
of the event when
планирует,
it should be deployed. So therefore, it is planned.
сервис вычитывает эту очередь,
As soon as the time comes, the server
соответственно,
and the service read the queue, and they provide for the steps for the further deployment. There are two possible status, whether it's ready or error. And that's why there's also a specific delete status when the time comes to end the lifetime of the test bench. And there is also a manual delete option. So ultimately, what did it make to the methodology? There's the uniform format of the specification of the products, the uniform
и, собственно,
application format, and the manifest description, the status of the stand test, and the stages of the different life cycle, and the interaction of the product between each other. So right now, I would like you to take a look at the implementation option.
Система названа автоинфраструктура,
This system is entitled Auto Infrastructure Manager,
которая располагается
PT AIM, which is
разработки DIT в
in the DIT Kubernetes platform, which provides the basis
фаерволов, там.
of the gateways, firewalls, etc.
На схеме представлена контекстная диаграмма
So here we can see the context diagram revealing
системой.
how the users interact with the system with the use of the API pipeline
Через UI.
and
И можно
UI.
видеть пример взаимодействия внешних
You can see the example of the
через
external users interacting it
эти пользователи,
through the
например, стенды
positive portal where they make requests for training purposes. The system itself addresses API
систем виртуализации и
of the virtualization system or clouds. So
для
it provides
создания, для каких-то выполнений
for
команд.
different other commands.
Смотрим на архитектуру. Архитектура микросервисов.
Let's just take a look at the architecture. It's the microservice interaction. It interacts
И мы видим, что
by
справа
command
от
bus
команд
on the right-hand side
сервисы, которые
of this
выполняют конкретный этап.
command bus or command line.
При имеющемся манифесте
You will see that with the current manifest, we can easily scale up this solution by adding the controller
в манифест.
and a certain stage in our manifest.
Проблему масштабируемости.
That's how we resolved the issue of scalability
Развертывание
of products and their deployment schemes.
провайдеров, размещение ресурсов. На схеме видно, что
And resource
входная точка
use.
системы
the entry point of the system is in the API servers, which accepts the applications and it checks the user rights and uploads the specification of products through Git repository, and it sends it to the controller of the manifest generation. The API service works as a router, sends the feedback, exchanges information with the user interface, and it sends notifications. You can also see the billing service, which is the service which collects analytics from different other parts, and it shows you the resources and helps planning for missing resources or resources required. Like I said, API is used to interact with the user interface. There is an API to support the pipeline. The user interface is required to create the tickets, to create applications, and it provides for finding the tickets. It uses the multi-tenancy model, and it provides the opportunity to check the analytics of the use of the resources, as well as purchasing options, planning options for purchasing. What have we so far implemented? We have implemented the system, we have developed the methodology. All of the services are ready except for the billing service. And we would have to scale up for the providers, the installation schemas. So basically, we are working for expanding of the functionality. This is it. Thank you very much for listening. Those of you who like this presentation, please use the QR code and you may give my presentation a like there if you like.
Запросы через QR-код, да. Вопросы.
Yes, all of the questions should be sent there in written form by using the QR code. This is the QR code for questions.
Так, первый вопрос. Есть...
So, question number one. There are fixed stands, medium, large. Sometimes the product load actually changes. Do you think about using the scalable stands? Well, obviously, we are considering first and foremost the tasks that we do with test benching, tests, and there are some performance profiles shown by the developers. The configuration is tested, so of course we can make this configuration and customize this solution.
По, например, расширению или масштабированию ресурсов.
And expand the resources.
А можно вернуть слайд с QR для вопросов?
Can we run back to the slide with the QR code for questions?
Спасибо. Можно так задать вопрос, если хочешь.
You can answer this question. You can ask this question like this. You have established the dynamic infrastructure. How do you verify this? So when we prepare the infrastructure, we prepare whether there is some resources needed in the infrastructure, and as we deploy the product, we test
Ну, во-первых, до еще
Well, first of all, before we accept the application, we check for the distributives and periphery available. And at each stage, we have the deployers. They check and verify whether this product can be deployed.
Это лучше в кулуарах.
I think you should take it offline. After this presentation, you may discuss it on the sideline. Dmitry, idempotency, how have you,
на самом деле реализовано просто
how did you resolve that? It's simply resolved by reinstall. You should reinstall it. You once again make a query to the stand, the test bench, and it reinstalls. So as you deploy this test bench and
Все. Окей.
there is a mistake, the next retry will erase it. Exactly.
состояние инфраструктуры.
How do you store the state of the infrastructure? The state of the infrastructure.
Состояние инфраструктуры после ее
So
создания.
the state of the infrastructure, once it's been established, is stored in an image,
Подтягивается потом.
in an image which is pulled up
После его создания мы его кэшируем и подтягиваем, если
after its creation. We pull it up if we have an additional query
просто
for the
подтягиваем
same stand.
такого образа.
So we pull it up and deploy it.
Ну, примерно так. Грубо говоря, да.
Something like that, yes,
Насколько
exactly.
реально использование подобной
Is it realistic to use this system to deploy this system in ERG infrastructure when you don't have any access to the external network?
Такая функция есть,
You see, there is such a function. It is
который просто
done by the deployer
зависимости
who actually
независимый инсталлятор.
prepares the independent
Соответственно, инженеры поддержки просто
installation, and the support installation engineers just come to the customer and deploy it with the prepared infrastructure. How much time does it take to prepare all of the manifests and configs when you have to prepare the data? There's lots of data, and which team, how much time each team spent for it? All of the manifests are generated automatically by the system. You just need to prepare the configuration
и
of the product itself.
они уже
So
практически
basically,
описаны, и сколько
they are all
времени
described, and
это занимает. Но я думаю,
how
что
much time it takes, I don't know. It doesn't take too much time
команда, которая
because it's the team that prepares them is specializing in the deployment of these products. There are not so many parameters to check and verify, and we've seen this in the examples. A sudden question: what are the oldest OSs that the system can deploy? Can it cope with Windows XP? Debian 10, Debian 11 didn't do.
Astra,
Astra,
XP вряд ли.
it's highly unlikely that it will support Windows XP.
Ну, я думаю, да.
Так,
I think so, yes. We're running out of questions. Dmitry,
лучший.
you will have to select the best one.
Лучший вопрос. А можно глянуть?
Can you just take a look at them?
Хорошо, нет вопроса, а где я?
Okay, it's good that we don't have the question like what this presentation is all about.
Давайте вот этот вопрос про фиксированные размеры нагрузки.
So let's just take this question number 2 about the fixed load. It's from Sergei Pashkov. So if you're here, please come up to pick up your piece of merchandise. Thank you, Dima.